In this video, we're going to be writing an equation from transformations. In number 1, it says the graph of f of x is equal to x squared is shifted 3 units to the left and 4 units up to obtain the graph g of x. Write the equation of g of x. So we're going to start with f of x, which is x squared, and the first thing we want to do is shift it 3 units to the left. And when we shift x squared 3 units to the left, we have x plus 3 squared. Remember that a horizontal shift has the opposite direction of the sign, so because we want to go left 3 units, we're going to have a plus 3 inside the parentheses. And the next thing we want to do is the vertical shift, so we want to go 4 units up. And if we shift it 4 units up, we're going to have x plus 3 squared plus 4. Because the vertical shift is the same direction as the sign, so we have a positive 4 because we're going up. So then we can say that g of x is equal to x plus 3 squared plus 4. In 2, it says the graph of f of x is equal to the square root of x is reflected over the x-axis and moved 4 units up to obtain the graph of h of x. Write the equation of h of x. So we're going to start with our function f of x is equal to the square root of x. And we have a reflection over the x-axis, and we have a vertical shift. So we want to do the reflection first and then the vertical shift. So we're going to have reflected over the x-axis. And if we reflect over the x-axis, then we put a negative sign out in front of our function. So we're going to have negative the square root of x. And now we want to move 4 units up. So move 4 units up. And since we're moving up, we're going to have a positive 4. So we're going to have negative the square root of x plus 4. So our h of x is equal to negative the square root of x plus 4. In 3, it says write the equation of the graph below. To check your answer, choose a point on the graph and make sure it satisfies it. And the first thing I'm going to do is create a base function. And here, this looks like our absolute value function that's shifted left and shifted down and reflected over the x-axis. So I'm going to start with y is equal to the absolute value of x. And it might help if we can look at the function y is equal to the absolute value of x. So I'm going to put that into the graph. So now with the starting function y is equal to the absolute value of x in the picture, we can see that the point that I'm going to track is 0, 0 on the original function, which is where our function comes to a point. And then I'm going to take a look at how it shifts. So the first thing we want to look at is the horizontal shift, and we moved 1, 2, 3 units to the left. So if we move 3 units to the left, we're going to have the opposite sign inside of our absolute value. So 3 units left gives us y is equal to the absolute value of x plus 3. And now the second thing we want to look at is the reflection over the x-axis. So when we reflect over x-axis, we're going to have the negative sign out in front of the function. So we have y is equal to negative the absolute value of x plus 3. And then the last thing we want to look at is the vertical shift. And we move down 1 unit. And for a vertical shift, the sign is the same as the direction we're going. So we're going to have y is equal to negative absolute value of x plus 3 and then minus 1. And now we want to test a point. And I'm going to test where the function comes to a point. So I'm going to test negative 1, 2, 3, negative 1. So we have the point negative 3, negative 1 going into our function. So y is equal to negative 1 is equal to negative the absolute value of x, which is negative 3, plus 3, minus 1. And now we have negative 1 is equal to negative 3 plus 3 is 0. And then the minus sign gives us negative 0, which is still 0. So we have 0 minus 1. And negative 1 is equal to 0 minus 1. And that's all for the video on writing an equation from transformations.